Hello my dear students. So today we'll discuss about a parallax method. The parallax method is particularly for a measurement of length. In that, the larger measurement of length. For example, we have to measure the distance of any star or a planet from the surface of Earth. That will be the parallax method. Let us see what is parallax method and how to measure the larger measurement of length. So here the name itself is tells parallax. So what is parallax? Very simple thing. The shifting of the position of an object, with respect to the background. Shifting of position of an object with respect to the background. That we will call it as a parallax. Usually in our eye it will happen. For example, if you hold a pen or pencil or a chalk holder, you observe this pen with one eye and with respect to the background and note down the position where it is located with respect to the background, and you have to close another eye and observe it just like a left eye. So there will be a shifting of the position of an object. So that shifting of the position of an object with respect to the background is, we will call it as a parallax. So we have to use the same method here. We are applied that parallax to measure the larger distance. The parallax method. Here, simple one. So, far away distance, a star is there. I represented with S, denoted by S. Assumption that any star or any planet is there at a far away distance. Now, this will be considered as an Earth. This will be considered as an Earth surface, the semi-circle I draw. Then I have to observe this star with two different positions on the surface of the Earth. Two different positions means 2 point of observations. So for example, here I'll take as point A. This is one of the point of observation of this star at this point, surface of the Earth, and I consider another point, means another position on the surface of the Earth, that is B. Now, this will be the distance between the two position of observations, that will be denoted by the symbol B, that is, we will call it as a basis. So, S indicates any star, okay, and here I already mentioned. So B indicates that basis. So what is basis? The distance between the 2 points of observations. Now I will take the direction of observations. Direction of observation. If the person A, for example, the person 1 is observing this star at the position A, is his direction, the observation direction is like this. So I will draw like this. This is the direction of observation of person 1 at A, position at A. Now, similarly, if the B also observing the same star at a time, but his direction of observation is like this. Just like his direction of observation is like this. So BS will be the direction of observation of person 2. AS is the direction of observations of person 1 in the position A. So here AS and BS are the direction of observations. Direction of observations. observations, and A and B are the 2 points of observation. 2 points of observation. 2 points of observations on the surface of Earth. That we already know. Here, approximately I'll take the distance AS and BS will be D. AS and BS will be D. The distance AS is approximately equals to BS, which is equals to D. I will consider as a D. Okay. Now, there will be an angle at a point of or a position of the star, where position of the star is there. So there will be an angle between the 2 direction of observations. Angle between the 2 direction of observations. That will as a theta. So here theta indicates the parallactic angle. Parallactic angle. Parallax angle or parallactic angle. Now, this theta is the parallactic angle. These are the 2 points of observations A and B. AS and BS are the direction of the observation. Now, we already familiar with the plane angle and arc length formula and everything. So, in a circular motion, because we already discussed it. So, here, according to that arc length formula, S is equals to R theta. I hope I will redraw that. So this will be the center of the center of the circle. Imagine the circle you just take. This will be the part of that circle. This will be the radius. This is theta. This will be the O. And if I consider this is position 1 and position 2, the distance between position 1 and position 2 is considered as an S, where S is the arc length. So arc length formula is S is equals to R theta. This will be the R radius. Okay, S is equals to R theta. Just I'll compare this situation with respect to observations. Whatever the model we made, this observations. Simple way, I am comparing this S with O. I am comparing this S with O, means center of the circle. Imagine that the position of any star or a planet, any star or a planet, any star or a planet. So that will be the position I will consider as a center of the circle, and the OP1 and OP2 will be the radius figure. So this is the center, means I will consider this B. Just like AS and BS will be considered as a radius of the big circle. Imagine that AB will be the arc length. AB will be the arc length. How here P1 and P2 are there? Like that. Here A and B are there. Though here I will take as the distance A and B are the basis. There it will be arc length. So if I compare this model with respect to the circular motion, in that circular motion arc length concept. So if I compare this with the S is equals to R theta, now I will write as a B is equals to, because the basis, the distance between A and B, here imagine that A and B is the arc length of a very big circle with a center S and radius D. Therefore, B is equals to D into theta, where B is equals to D into theta. Now, by using this formula, we can easily find the distance D. Because one thing keep in your mind, here theta is very small. Theta is very small, and the distance B is much lesser than D. So because of that, we applied the circular motions. We applied the concept with respect to the circular motion, particularly arc length. because the two things you people have to remember that theta is very small. Theta is very small because if you observe the star or a planet from the two position on the surface of the earth, usually the angle is very small, lesser than 1 degree or 2 degree or lesser than 10 degree. Imagine that 10 degree. Usually you know that 10 degree means only this much it will comes. 10 degree, 20 degree, 30 degree, 40 degree, 90 degree. This is the 90 degree. So usually 10 degree means only this much angle. So for that purpose theta is very small and b is much lesser than d. The distance from the surface of the earth to star, if you compare that distance with the distance between the 2 points of observation, so b is very small compared to d. Then with this condition we can say that b is equals to d into theta. So by using b is equals to d into theta, by using this formula we can easily find the distance from the surface of the earth to any star. So already I consider as is approximately equals to bs, which is equals to d. Here I will take as that will be the distance from the earth surface to any surface to the position of the star. Position of the star. Yes. Okay. Now by using this formula we can easily find the distance d value. B is equals to d theta. By using this formula we can easily find the d value. That is, we already know b is equals to d theta. I just rearrange that terms. D is equals to b divided by theta. So where d is the distance from the surface of the earth to any star position or any planet positions, b is the basis, that is distance between 2 points of observations, theta is the angle, particularly parallactic angle between the 2 directions of observation at the position of stars. So by knowing the value of b and theta, you people can easily find the distance of the any star from the surface of the earth. So this is an parallax method, particularly indirect method for measuring the length. In that also the larger measurement of length, not a smaller measurement, a larger measurement of length. So if by knowing the value of b and theta, by known value of just like now value of b and theta, we can easily find the value of d, distance d. I hope these things are clear. So this is about a parallax method. Particularly we are comparing this method and this model with the circular motion, in that particularly the arc length formula, because of this. I hope it's clear. So in the previous classes and all we discussed about the measurements of length, what are the direct methods are there. So we discussed that. Now it is an indirect method. Keep it in your mind. Usually this one will ask for a 3 mark in your theory examinations, final examinations. So or also for calculation purpose they will give the value of b and theta. You people have to find the value d in a numerical part. Usually will ask for a 2 mark, and this is an important for your competitive also. So by using in the reverse way, you can also find the diameter of the moon also by using this parallax method. Just like you just imagine the opposite, diametrically opposite points are considered as the 2 points of observations, and the surface of the earth will be the just like a star position, like that. So you people have to observe the diametrically opposite points on the moon. you have to observe 2 directions you will get and angle, parallactic angle you will get. So based on that we can find the diameter of the moon also by using this parallax method. So this is about a parallax method as well as measurement of length. So I hope these things are clear. Thank you.